Okay, so this is data sufficiency worksheet on speed, distance, time, and work rate time. I've compiled 5 questions on speed, distance, time, and 7 questions on work rate time, right? So let's begin. As usual, remember to solve the worksheet first and then come on to the uh, video for solutions. This is a solutions only video meant for advanced learners of math or GMAT. Thank you. Train A and train B travel on the same track in the same direction at their respective rates. Hang on. So, hang on. Yeah, all right. At their respective speeds without any halts. Okay. What is the distance between the two trains at 10 p.m. on Monday? 10 p.m. on Monday. Yeah. Ignore the length of the trains in calculating the distance between them. Train A is traveling at an average speed of 80 miles per hour. Since it began its journey at 1 p.m. on Monday from junction T. So what is the distance between the two trains at 10 p.m.? So obviously from A, we only get information for train A. And so A and D is out. We left with B, C, and E. Train B began its journey at 5 p.m. on Monday from junction T. Yeah. At an average speed of 100 miles per hour. So they're asking what is the distance between two trains at 10 p.m. on Monday. And obviously B is also out because it just gives you information on train B and not A. So we left with C and E. Taking both statements together, we know that both the trains leave junction T but different times, 1 p.m. and 5 p.m. So let's look at train A, 80 miles. So we have to find out by 10 p.m. train A would have traveled what distance? It would have traveled for 9 hours, and therefore the distance would be 9 8 72, 720 miles. Yeah. And B would have traveled for from 5 p.m. to 10 p.m. is 5 hours. So that's 500 miles. Okay. So what is the distance between the two trains at 10 p.m.? So at 10 p.m., the distance between them is 220 miles. So we get an answer. C. C is the answer. Second question. Okay, what is the average speed of the entire journey from city A to city C undertaken by Jerry if he only traveled by car? So Jerry traveled for 5 hours without halt from city A to B at an average speed of 60 miles per hour. So A doesn't give the answer, D doesn't give the answer. It's between B, C, and E. Jerry traveled for 9 hours without halt from city B to C, covering a distance of 400 miles. So that doesn't tell us between A and B. So B statements on its own is out. So we left with C and E. Okay. Now when we take both statements together, and the question is what's the average speed of the entire journey from A to C? So the average speed formula is total distance over total time. Yeah. So city A to city B, the total distance is 65 are 300 plus 400 miles out here, correct? So that's 700. And the total time, so time taken is 5 hours and 9 hours, 14 hours, correct? Yeah. So remember, we do not simply add the two speeds and divide by 2. It doesn't work that way, okay? Yeah. All right. So the answer is 700 by 14. which is 14 5 is 70 and 50 miles per hour. So C gives you the answer. Question 3. Okay. Okay. Nancy travels daily from home to work by local bus and then returns home via the same route route, sharing a cab with a friend. Okay. So what is the time taken for the entire journey to and from work? So going to work and coming back from work, what is the total time taken? Assume she traveled without any halts in either direction. So there were no halts taken by her. So A. Local bus travels at half the speed of the cab, covering a distance of 20 miles from Nancy's home to her workplace. So from A, we come to know that the distance between work and home is 20 miles. Yeah. And because it's stated out here, where is it? Same route, right? Returns home via the same route. So that means it is 20 miles while coming back as well, right? Okay. So, right. So we don't get to know the time because we don't know the number for the speed. So A is out, D is out, B, C, or E. Time taken to travel home from work is exactly 20 minutes. All right. But yet we don't know the speed of coming back, going, right? We don't know anything. Just we know the time. All right. So B doesn't answer. Taking both together. Now both together, we come to know that the return journey is 20 minutes. Yeah. And the return journey is through cab. Right? It says out here, cab with a friend. All right. Returns home via cab. So if the cab time is 20 minutes and the distance is 20 miles, correct? And it says out here that the bus travels at half the speed, meaning the time is going to be double, right? It's going to be 40 minutes, right? While going, because the speed is half that of the cab. So clearly, if the cab is taking 20 minutes, then the time is going to double out here because the speed is half. Half the speed, double the time, right? Double the speed, half the time, correct? But it's half the speed, so double the time. So therefore, together we get the answer. All right, we come to know that the time taken for the entire journey is 60 minutes or 1 hour. Fourth question. At 1 a.m. on Tuesday, train A and train B are 20 kilometers apart, traveling for Jaipur on a straight route and in the same direction on two different tracks parallel to each other. Okay. All right. But they're 20 kilometers apart, right? Now the question is which train will reach Jaipur first, assuming there are no halts taken by each train. Ignore length of the train and calculating the distance between them. Now train A and B are traveling at an average speed of 80 and 100 respectively. So we know that they're 20 kilometers apart and they're traveling at 80 and 100 respectively. But we have to find out which train will reach Jaipur first, right? So clearly, it depends on two things. One is they're 20 kilometers apart, but is train A here or it's A here? You know, which one is, you know, it could be either way. B could be ahead. Imagine this is Jaipur out here. So A could be ahead or B could be ahead. We don't know. So that's one thing. And second thing is we don't know the distance. Uh, you know, at 1 a.m., what is the distance from any of the trains to Jaipur? We don't know that. So A doesn't answer. D doesn't answer. B, C, or E. Okay. At 1 a.m. on Tuesday, train A is exactly 60 kilometers away from Jaipur. Okay. All right. So we know that 20 kilometers apart, and we know that train A is 60 kilometers away from Jaipur. So this is scenario one. Okay. So A is ahead of B. A is 80 kilometers per hour, and B is 100 kilometers per hour. So let's find out the time taken by them. So A's distance from Jaipur is 60 kilometers. So at 80 kilometers in 1 hour or 60 minutes, I would say, to travel 60 kilometers, it will take how much time? So 60 into 60 upon 80. 23s are 24s are 4 15s are 45 minutes. Correct. And B, 100 kilometers in 1 hour. Okay. So the distance between B and A is 20 and plus that 60. So 80 kilometers. So this I'll take it as 60 minutes again. How many minutes? So 80 into 60 divided by 100. So that's 48 minutes. 10101010. Okay. Yeah. So clearly we know that A reaches first. Which train will reach Jaipur first? Now scenario 2. Okay. Scenario 2, A is here, 20 kilometers. B is here. And if you look at the second statement, it says 60 kilometers away from Jaipur. So this is 40 kilometers out here. Speed of B is 100 kilometers per hour. Speed of A is 80 kilometers per hour. So clearly, the slow one will never be able to overtake B. Will never overtake B. Okay, because it's slower than train B. So B is going to obviously reach first, right? And the distance is also less. So therefore, in one situation, we know that A reaches first, 45 minutes. This is B's time. Yeah. So this calculation is for B. That calculation is for A. So when we calculated, came to 45 minutes. So A reaches first, scenario one, scenario two, B reaches first. Right? It could be this scenario also, right? They're 20 kilometers apart, B is ahead of A. Correct. So therefore, B doesn't answer, obviously. 1 a.m. on Tuesday, train A is exactly 60 kilometers away, but we don't know their speeds, nothing. So together, yeah, also it doesn't answer. Because together also we're getting which train will reach Jaipur first. It depends on which scenario it is. So cannot be answered. E. Fifth one. The last speed time question, then the work time questions have come up. From two opposite ends of a straight pathway, Anne and Jenny walk towards each other at an average speed of 6 kilometers per hour and 5 kilometers per hour, respectively. Okay. Find out after how many hours will they cross each other's path, assuming they do not take any break and they began walking at the same time. So let's assume this is Anne and this is Jenny. Yeah. So Anne is walking towards Jenny. Jenny's walking towards Anne at the following speed: 6 kmph, 5 kmph. Find out after how many hours will they cross each other's path. Okay. So Anne and Jenny were 11 kilometers apart after 2 hours. Okay. So right. So in 1 hour, Jenny would have traveled 5 kilometers and would have traveled 6 kilometers. This is after 1 hour, correct? After another hour, Jenny would have covered 5 and Anne would have covered 6. So Anne and Jenny are 11 kilometers apart after 2 hours. Correct? Correct. So if you realize that every hour, cumulatively, they're traveling 8 kilometers, 5 plus 6, 5 plus 6. So in 3 hours' time, in the next hour, they will meet across each other's path. Make sense? Right? So therefore, how long, how many hours will they, after how many hours will they cross each other's path? They'll cross each other's path in 3 hours' time. So A answers. Okay, A answers, so it's either A or D. Next one. When Anne completed a distance of 9 kilometers, they were 16 and a half kilometers apart from each other. So again, when Anne completed 9 kilometers, so we have 6, right? And 3. So clearly we know that in 1 hour she can go 6 kilometers. So 3 kilometers will be half an hour. So this is 1.5 hours time. All right. So remember they both began at the same time, right? So obviously if she started for 1.5 hours, Jenny will cover in 1 hour 5 kilometers, and in half an hour she'll cover 2.5 kilometers. Correct? So that is also 1.5 hours, right? Yeah, right. So we have when Anne completed a distance of 9 kilometers, they were 16 and a half kilometers apart from each other. Right. So now we know that when she completed 9 kilometers, she had traveled for 1.5 hours. So clearly, this she also traveled for 1.5 hours and she covered 7.5. And between them, it is 16 and a half kilometers apart. And as you can see, this is 9 and this is 7.5. This is also 16 and a half. Correct? Right. So therefore, it will take another 1.5 hours to cover 16 and a half, right? So in the first 1.5 hours, 16 and a half. In the next 1.5 hours, they would cover 16 and a half again. So therefore, 3 hours again. We got the same answer. D, each alone answers the question. Slightly tricky, but can be done. Okay. It's a tricky one. Right. Work time. J can complete a task in 8 hours, whereas John can complete the same task in 5 hours. If they both work at a uniform rate without taking any breaks, then in how many hours will John complete the task if J had completed a fraction of it alone before John took over? Then in how many hours will John complete the task if J had completed a fraction of it alone before John took over? All right. So we have to find out in how many hours will John complete the task if J had completed a fraction of it alone before John took over. All right. So out here, we know that J can complete the entire task in 8 hours, whereas John can complete the entire task in 5 hours. Correct? Same task. And we have to find out the fraction that the time taken for John to complete the remaining work after Jay had worked on it for a few hours. Something like that. Okay. A. When John took over the task, Jay had been working on it for exactly 3 hours. And they've mentioned worked at a uniform rate without taking any breaks. So clearly, if Jay worked on it for 3 hours, right, and he can complete the entire task in 8 hours, then he's completed a fraction of it alone, which is 3/8. 8 hours he can do the entire task, right? Then in 3 hours he can do 3/8 of the task. Correct? So then John is going to do 5/8 of the task, right? Remaining, right? before John took over. So how many hours will John complete the task? So in how many hours will John complete the remaining task or whatever the case may be? Yeah. So case out here is 5th of the task. So we know that in 5 hours John can do in five in meaning one whole task. John takes 5 hours. So 5/8 of the task John will take how many hours? So we can do the math. 25 by 8 hours. We get the answer basically. So A answers, B, C, and E is out. It's either D or A. Statement B. Time taken by John to complete the entire task alone is also the time J took to complete 5/8 of the task alone. Time taken by John to complete the entire task alone, that is 5 hours, is also the time J took to complete 5/8 of the task alone. Okay. See, the time taken by John to complete the entire task alone is also the time J took to complete 5/8 of the task alone. So this is a information which we can get from the question stem itself. It is just given to us in a evaluation way. Like if you were to evaluate the question stem that J takes 8 hours to complete a task alone, and that same task John can do it in 5 hours. So if John completed the task in 5 hours, then in those 5 hours, J would have completed the same task, completed 5th of the task. So that's all it's saying. So B is essentially redundant. It's already given in the question stem. If you evaluate question stem information, you'll get B, correct? Time taken by John to complete the entire task alone is also the time J took to complete 5th of the task alone. So that's not giving us any answer. So A alone is the answer. Okay. Yeah. Right. So I think the idea is to confuse you with this fraction and this fraction. It's not the thing. Yeah. Right. Okay. Right. Anyway, so this B statement, yeah, is not coming out the way I intended it to because it's ideally if you strictly go with the way I've worded the question, then you might assume that the fraction is 5/8. That the time taken by John to complete the entire task alone is also the time J took to complete 5/8 of the task alone, right? So it seems that um, J completed 5/8 of the fraction, so 3/8 is remaining. It's the other way around of A. So one could assume that how many hours will John take to complete the task can be answered using B. The only thing is that in this situation, the fraction is 3/8 because 5/8 is done by J, then 3/8 is to be left for John, but that's not how it was intended. It was just intended to probably I need to plug in a word if the time taken by John to complete the entire task alone is also the time taken, something like that. So that way B becomes redundant. So we'll go with A for the time being, yeah, right. So we avoid the confusion out here. Yeah. Anyway, let's move on. Question 7. Machine A can manufacture 1800 Type 1 car accessories in 12 hours working alone. If machine B alone can manufacture 3000 Type 1 car accessories in 10 hours, then how much time would it take machine C to manufacture 19,200 Type 1 car accessories working alone? So we need information for C. Let's look at A. Machine A and B together can manufacture 10,800 Type 1 car accessories in twice the time taken by machine C alone to manufacture the same number of Type 1 car accessories. So out here, we know that A takes 12 hours for 1800 and B takes 10 hours for 3000. Yeah. So if we take a number which is common to both, like 60 hours, so in 60 hours, A would have, machine A would have manufactured 12 5 are 60, so 5 times this, so 9,000. And in 60 hours, that is 6 times 10, so it'll be 6 times 3,000, so that's 18,000. So together, machine A and B together can do 27,000 in 60 hours. So for 10,800, sorry, 1,08,000, 108,000, yeah, in how many hours, right? So that is, so instead of doing unitary method, I'll just double this. So 120 hours, it is 54,000, right? 27,000 in 60 hours, 120 hours, 54,000, and then 108,000 to 40 hours. And that is the time taken. Machine A and B together can manufacture 108,000 Type 1 car accessories in twice the time taken by machine C alone. Therefore, C alone would do 108,000 in 120 hours, right? Correct. And once we know this, that 108,000 in 120 hours and 19,200, how much time would it take machine C to manufacture 19,200? Correct. And then we can use the unitary method and get to the answer like this. This zero and these two zeros will cancel out with these three zeros, right? And then we got 108, so 12 goes into 108 9 times. And then we got 9 twos are 18, 12, 9 ones are 9, so 21 hours. So how much time would it take machine C to manufacture 19,200? It would be 21 hours and 20 minutes. Correct? A answers. So B, C, E is out. So it's left with A and D. Machines A, B, and C can manufacture 5,500 Type 1 car accessories in exactly 4 hours. Okay. So we know that 1800 in 12 hours. So if it is 4 hours, yeah, 4 hours, A will do 1/3 of 1800, right? Because 12 hours and 4 hours. So 4 is 1/3 of 12. So 1/3 of 1800 is 600. Then B, okay. So we know that 3000 in 10 hours. So in 1 hour, it is 300. 1 hour, 300. So 4 hours, 1200. Correct? So this is 4 hours. A and B did 1800. Out here it says 5,400. Correct? So how much should C have so that all of it together becomes 5,400? So subtract 1800 from 5400 and we'll get 3600. Correct? Right. So now we know that in 4 hours, C can do 3600. So for 19,200, it'll take how much? So 19,200 into 4 upon 3600. So 4 goes into, so 0 zeros cancel with 0 zeros. 4 goes into this 9 times. And then 9 goes into this 22, 18, 112. So again, the same answer we get. Each alone answers. Correct? We can solve the question using each alone. So D is the answer. Right. Eighth one. Five identical printers working together at a uniform rate can print 6,000 pages in 120 minutes. If 6 more printers are added, then how long will it take all the printers together to print 40,800 pages? Okay, so 5 already there and 6 additional printers. Then how long will it take all printers together to print 40,800 pages? Now the important thing out here is identical and whether these 6 are those same identical printers or not, right? So once we figure that out, we can solve the question. Each of the 6 additional printers is of superior quality and can print twice as fast as each of those printing now. So clearly these 6 are different from those 5. But as we, let's see, um, twice as fast. Okay. So 6,000 pages in 120 minutes. So in 1 minute, it'll be 50 pages. Now remember, these are 5 printers doing 50 pages, identical ones at a uniform rate. So clearly it will be 10 pages if we divide 50 by 5. So 10 pages in 1 minute, right? For each printer, each of the 5 printers. Okay. Now each of the 6 additional printers is of superior quality and can print twice as fast as each of those printing now. So the 6 additional ones can do 20 pages in 1 minute, right? Each of the 5 and each of the 6 printers. So now together they'll take how long to print 40,800 pages? So together we know they can do 30 pages. No, sorry. First we have to multiply with the 5 out here and multiply this with 6. So 50 pages and 120. So together 170 pages in 1 minute. Correct? So 40,800 pages in how many minutes? So 40,800 into 1 by 170. So that is 17 ones are 17. No, 17 twos are 34, 68, 17 fours are 240 minutes. Is 4 hours. Correct. So A answers. A answers, B, C, and E is out. It's either A or D. Second part. Each of the 6 additional printers can print 10 more pages per minute than the each of the 5 10 more pages per minute than each of the 5 printers currently in use. Then the out here the should be deleted. So yes, I'll be obviously correcting this and making the worksheet available, right? This and also that be part of question number 6 or 7. Yeah. Okay. Right. Each of the 6 additional printers can print 10 more pages per minute than each of the 5 printers currently in use. Right. Okay. So let's solve this. So first of all, we found out from this information that 50 pages are done in a minute, and therefore it is 10 pages in 1 minute for each of the 5 printers. Okay. So 10 pages per minute each printer. Yeah. So each of the 6 additional printers can print 10 more pages per minute than each of the 5 printers currently in use. So we know that 20 pages per minute each for the new ones, current and new. And that's exactly what we got out here as well, right? And then we had to multiply this with 5, this with 6. So we ended up getting 50 and 120, 170, right? Pages per minute. So for 40,800 pages, how many minutes? So that's the calculation we did out here. So it's the same thing. We get the answer using B as well. So A is out, D. Each alone can answer. Again, a tricky question. Okay. So D is the answer out here. Question 9. Okay. An empty water tank can be filled up to brim by water pump A. Up to brim meaning till the top. Yeah. Full capacity. So an empty water tank can be filled up to the brim by water pump A, which functions at the rate of 50 gallons per minute. Okay, 50 gallons per minute. That's for A. Another water pump B can empty the water tank at a, so one is filling it up and one is emptying it. Okay, right. So another water pump B can empty the water tank at a rate slower than water pump A. Okay, right. Find out if both water pumps are switched on at the same time, then how long would it take for this empty water tank to fill up to full capacity? Okay. So this statement out here was not really required, but it's okay. It's just to let you know that if the rate of the one which is emptying it is greater than the rate of the one which is filling up, then the water tank will never fill up to the capacity, full capacity. All right. So just to let you know that it is lesser. The rate of emptying is lesser than the rate of than the pump which is filling it up. Anyway, so A, we have to find out how long will it take for this empty water tank to fill up to full capacity if both the pumps A and B are switched on at the same time. Okay. So water pump A functions at a rate of 10 gallons per minute faster than water pump B. All right. So from A, we know that B is 40 gallons per minute, right? If it's 10 gallons per minute faster, then B has to be 40 gallons per minute, right? Correct. So if they both are switched on, we have to find out how long would it take for this empty water tank to fill up to full capacity, and full capacity is what we don't know. If we know the full capacity, then A would have answered. We don't know that from A. So A is out, D is out. We're left with B, C, or E. All right. Okay. If water pump B functioned at a rate of 10 gallons per minute faster than water pump A, so we know A is 50. So this is the only information we have from the question stem. And now they're saying if, now remember, we got to avoid this information for the time being, okay? Because this is from A, statement A. Anyway, so if water pump B functioned at a rate 10 gallons per minute faster than water pump A, so B out here, they're saying if it was 10 gallons per minute faster, then it would have been 50 gallons per minute, correct? Right. Then a full water tank could be emptied by water pump B alone in 100 minutes. So basically it's saying if it was 10 gallons per minute faster, meaning 60 gallons per minute, then in 100 minutes, the entire water tank could be emptied, and a full water tank could be emptied by water pump B alone in 100 minutes. So we now know that 60 into 100, 6,000 gallons is the capacity. Correct. But they're using the word if. Correct. If the water pump be functioned at a rate of 10 gallons per minute faster. Now that if is not the factual information, right? But we do know that the water tank would have been emptied by B alone in 100 minutes, which means that the capacity of the water tank is 6,000 gallons. But we don't know the actual thing about B, the actual rate of pump B. It's only saying if the water pump function. So therefore, B also doesn't answer on its own. But from B, we came to know this. And from A, we came to know this, 40 gallons per minute. So now together, they'll answer the question, because together, we know that together, when they both are switched on, correct? Yeah. And because B is slower than A, then every minute, only 10 gallons is filled up. So therefore, to fill up 6,000 gallons, it'll take how many minutes? So 6,000 into 1 by 10, it will take 600 minutes, which is 10 hours, right? 10 hours into 60 is 600 minutes. So it's 10 hours. So together it answers how long would it take for this empty water tank to fill up to full capacity? 10 hours. Ease out. Okay. Question 10. Three machines A, B, and C can recycle 4 tons, 5 tons, 6 tons of plastic every hour, respectively. If machine B and C recycled a portion of the 510 tons of plastic by working together, then how long would machine A take to recycle the remaining portion of the plastic working alone? All right. So we need to find out what portion B and C is recycled, and then the remaining portion we come to know, and we get to answer because we already know the individual uh, rates, right? So focus on how much did B and C recycle. Okay. A. Together machine B and C recycle plastic for as many hours that it would have taken all three machines working together to recycle 510 tons of plastic. Okay. So let's find out all three would have taken how much time to recycle 510 tons of plastic. So we know that every hour, three of them can do 4 plus 5 plus 6, which is 15 tons every hour. Correct? So therefore 510 tons, how many hours? So unitary method, 510 into 1 by 15. 15 threes are 45, 60, 15 fours are. So 34 hours. Yeah. And that is also the time taken by machine B and C. Okay. So B is 5 tons. So 34 hours taken by B and C, right? Plus 34 hours taken by C. So from here, we come to know it is 34 times 5 plus 6, which is 34 times 11. So that is 11 fours are 44, 11 threes are 33, 374 tons. All right. So as you can see that 34 is taken by all three of them, 34 is taken by B and C. So whatever is remaining is the 34 times 4 part only, right? So we'll just do the math quickly. 510 minus 374 is 126, 136. Now, what I was trying to tell you is that this is nothing but 34 hours into 4. That's what I was trying to tell you, right? Anyway, so then how long would machine A take to recycle the remaining portion of the plastic? So remaining portion is 136 hours. I'm sorry, 136 tons. And so if machine A takes 4 tons, recycles 4 tons every hour, so for 136 tons, it'll take how long? So it'll be 34 hours. That's what I was trying to tell you. But it's okay, we'll do the math. Okay, 34 hours. So A answers, B, C, E is out. It's either A or D. Yeah. The portion of the plastic recycled by machine A alone is equal to 4/15 of the entire portion that needed to be recycled. So the portion that how long would machine A take to recycle the remaining portion of the plastic working alone? So the portion of the plastic recycled by machine A alone is equal to 4/15 of the entire portion. So 4/15 of 510. So that is 15 goes into this 34 times. And so it is 120, 136, right? 136 tons is a portion of the plastic recycled by A alone. And that now we have to find out how long would it take to recycle the remaining portion. So remaining we know. So how long will it take? So we know that A takes 4 tons, recycle 4 tons in 1 hour. So 136 tons in how many hours? Correct? So that's 136 into 1 by 4. So 4 3 that 12, 16, 34 hours. So how long? So each alone answers. B is the answer. So guys, this one could be very confusing. You just go with what is given to you and not think more on this. Yeah. Anyway, question 11. 11th question. Okay. 6 identical machines can dispense 2,000 coffee sachets in 9 hours. How long would it take 27 such machines to dispense 4,000 tea sachets? How long? So let it be tea. Now, obviously, since it's tea sachets and coffee sachets, right? Otherwise, the question is solvable like this with this equation. So, okay, A, B, C, D, E. Since each tea sachet has the same weight, dimensions, and packaging as a coffee sachet, the machine would not be able to distinguish between the two while dispensing them. Hence, it would be important to have separate machines for tea and coffee sachets. What this tells us basically is that the machine is not able to distinguish between them, therefore, it will treat them as the same, right? And this is a fact given to us, and therefore we can use this information. We can treat that the coffee sachets and the tea sachets are identical in its dimensions, weight, and composition. All right. Now, this is something new that I've introduced out here. Yeah. Because it's really not giving us any numbers. It's just telling us. So it's a very descriptive question. So uh, I'm waiting for your feedback for this particular question because I am taking A as the way to solve the question, meaning it will solve the question. All right. So what is this expression I've written down out here? It is nothing but the expression when you know, like when two things are directly proportional, we use this expression. So we can compare this with machines and sachets. And when two things are inversely proportional, we use this expression. So you can compare this with the machines and the time taken, Like out here, it's 9 hours. Like, for example, if the sachets remain constant and the machines were to increase, then the time would decrease. If the sachets were to remain constant only, just remember this part. Okay. If the sachets were 2000, machines were increasing, then the hours taken would be less. So that is inversely related. So when it is machines and time taken, inverse relation, machines and sachets, direct proportionality expression. So when we combine the two, we end up getting that expression, which I'll write down as machines M1 time 1, and in this situation, sachets 1 is equal to machines into time 2 upon sachets 2. And that's how I got that expression. Machine 1, 6 machines, time 9 hours, 2000 coffee sachets. Second expression, 27 machines, time is what we need to find out for 4000 tea sachets. Okay. And if we solve this, what we get is 9 goes into 3, 3 goes into 6 2 times, 2 goes into this 1000 times, and this 1000 goes into this 4 times. So therefore, time 2 is basically 4 hours. Got it? And again, feedback for statement B also, each machine can dispense a tea sachet at the same rate as a coffee sachet. So again, using the understanding that the rate for dispensing a tea is the same as the rate for dispensing a coffee. So the machines are not distinguishing again. The rates are the same, me right? In the sense that they're not able to, they're able to dispense it at the same rate, right? So therefore the just because they're tea sachets, it doesn't change the rate of dispensing, and hence we can use the same equation again. And using the same equation, we get 4 hours. So this is, I need your feedback on this because I've framed it in a descriptive way where the question can be solved from within the question stem, but then the tea sachets and coffee is differing. So let me know. Let me know your feedback. Yeah. Last question. 12th one. Right. Right. How long would it take machine C to complete a task if machine A can complete the same task in 40 hours and machine B can complete the same task in 30 hours? This is a classic work time question. Together, machines A, B, and C can complete the task in 10 hours. So 1 by 10 is equal to 1 by A, which is 40, 1 by B, which is 30, and 1 by C is what we need to find out, right? All right. So 1 by C is 1 by 10 minus 1 by 40 minus 1 by 30. That is 1 by C. Okay. Therefore, if we use 120 as a common denominator, then 10 goes into 120 12 times, 40 goes into 123 times, and 30 goes into this 4 times. So that's 1 by C. Therefore, we know that we get 12 minus 7, 5 by 120, which is 1 by C, which is 1 by 24. Therefore, C is equal to 24 hours. So A gives you the answer. B, C, and E is out, either D or A. Second one, time taken by machine C alone to complete the task is 1.6 times the time taken by machine A and C working together on the same task. So the time taken by machine A and C is 1 by X is equal to 1 by time taken by A, which is 40, and C, which is 1 by C, Remember, we cannot use this information, right? Time taken by C alone to complete the task is 1.6 times the time taken by A and C. So this C is 1.6 times this X, because I'm assuming that X is the time taken by A and C together, right? So 1 by X is equal to 1 by 40 plus 1 by 1.6x, right? So I'm going to use the space on the top. So this 1 by x is equal to 1 by 40 plus 1 by 1.6x, right? So what I'm going to do is I'm going to multiply 10 in the denominator. Basically, I'm going to multiply 10 in the denominator on both sides. So what I get is 1 by 10x, right? 1 by 400 and 1 by 16x. Okay. All right. And that's it. Now I'm going to take 1 by 10x minus 1 by 16x is equal to 1 by 400, right? So now I'll multiply 400 on both sides, correct? So if I multiply 400 both sides, I get 400 by 10x, which is 40 by x. And I get 16 to the 32, 25 by x, which is equal to 1. Now 40 minus 25 is 15 upon x is equal to 1, right? So therefore that is x. So x is the time taken by A and C is what? 1.5 times x. That is 1.5 times, sorry, 1.6 times. So 1.6 times 15. So 15 6 are 90. 15 ones are 15 and 9 24. And one decimal goes out, so this goes out. So 24, 24. Each alone gives us the answer. So A is out, D answers. Yeah, that's it, guys. So remember, I will update the, the little portion out here. This one. If the time taken by John, something like this out here in this B statement out here, I will correct the statement and update this worksheet, right? Consider only A to be answering the question, yeah. And out here, I'll be correcting 10 more pages per minute than each of the 5 printers. So this there will go away, and that's it. Thank you.